Hello and welcome back. We're going to continue on with the 2015 AP Calculus exam. This is question number 2, and again, this is a calculator question for us. So let's go ahead and begin. At time t greater than or equal to 0, we have a particle moving along the xy plane, and they give us some unknown position vector, but they do give us the velocity vector as cosine t squared e to the 0.5t. Now remember, we know that velocity is the derivative of position. So since they're giving me velocity, I know that this is a derivative already. So I'm already starting to think ahead about what I may have to do. At t equals 1, they give us the particle is at the 0.35. So this is again an initial condition. So let's read what the first question asks us. It says, find the x-coordinate of the position of the particle at t equals 2. So again, I'm given velocity, but I'm looking for position. And since we know that velocity is the derivative of position, therefore we know that to get position, I have to integrate my velocity function with respect to t. So this is our FTC problem. This is FTC, pure fundamental theorem. So let's kind of review that real quickly. FTC is the integral from a to b of f prime of x dx. That's going to equal f of b minus f of a. So that's what we're going to do here. We are going to integrate. Now I'm only looking at the x coordinate, so I don't really worry about the y coordinate. So when I set this up, we're going to go from t equals 1, my known value, to t equals 2, my unknown value. And inside, and inside we're going to put x of t. Just the x part, that's its cosine t squared dt equals to the position, the x position at 2 minus the x position at 1. Now, unless you want to do series and sequences, we cannot do this by hand, so we're going to use our calculator here. So let's go and type this in. Menu 4, 3, type that in, from 1 to 2, and this becomes the cosine of, and I'm going to use x, they use t, x squared, and I just go to here, type in x, dx. And that gives me negative 0.443 equals x of 2, which is what I want, and my initial x position, remember my initial x position was 3. Therefore, I know that x of 2 would equal, if I add 3 to my equation here, if I just add 3, I get 2.55. Now I can leave it as 694, they'll accept it as a 6, or I can just round it up to 7. And there's our answer. Never box in your answer. So how many points would this be worth? Well, you would get 1 point for the integral, 1 point for just setting up your FTC right there. So this whole setup right here, basically 2 points. Well, sorry, using the initial condition was the 1 point, and then you get 1 point for your answer. So that's a quick and easy 3-point question, which is very nice after we did question number 1, which was pretty tough. All right, part B. It says between t equals 0 and 1, there is a point on the curve for which the line tangent to the curve has a slope of 2. At what time is the object at that point? So what they're looking at, we are looking at the idea that this function has a slope of 2. So we want to find out where is the slope equal to 2. And so we know how to do this from earlier. This is dy dx equals 2. But here's the problem. These are parametric equations. X is in terms of t and y is in terms of t. So when we set this one up, we have to look at them individually. So we're going to look at the change in y, the derivative of y with respect to t. We're going to look at the derivative of y with respect to t and the derivative of x with respect to t. So in our parametrics. So we already have those. That's just from my velocity. Y is just the y prime. My velocity is just going to be e to the 0.5t over x, which is cosine t squared, and we want that to equal 2 right here. And that's all we want to do. And we're going to solve this just using our calculator. Okay? using your calculator here, I am going to graph it. I like to graph these. Control divide e to the 0.5x over cosine x squared. Press enter. That looks pretty darn ugly right there. It might take a few moments to do that. There it is. Alright, and then I'm going to type in the other equation, just 2. Now, I know I have all this stuff over here negative, but remember, they did tell us t has to be greater than 0, so I don't worry about all of these. I mean, it's just like, look at those little asymptotes right there. Alright, anyway, so starting over here, so we're just looking for this one intersection point. Menu, Analyze Graph, Intersection, Enter, Enter. Now remember, the AP wants a little bit more than 2 decimal places, so when you hover over the 0.84, if you have the Inspire, just hit the plus sign, and you get t equals 0.840. And there you have your answer. And not too bad. You get 1 point for your equation, setting it up, and you get 1 point for your answer. So already we're at 5 points. I'm only halfway done with this one, so it's not that bad of a question right here. This should be pretty easy for you guys. Part C, it asks, find the time at which the speed of the particle is 3. So let's kind of review the formula for speed. Remember, speed is the magnitude of our velocity vector, which is the square root of x prime of t squared plus y prime of t squared. So this is just the formula, the square root of x prime of t, which is this cosine t squared plus y prime, which is this e to the 0.5 t squared. Remember, they already gave me x prime and y prime. Remember, that's what this is. That is x prime of t. That is y prime of t. They already gave me all of that. And I just want to know where this is equal to 3. And again, our trusty calculator. Clear out that memory. Doc B, get rid of that ugly thing. And I can just graph. I like to graph it. So we get the square root of cosine, open up the parentheses, cosine of x squared plus, open up a parenthesis, e to the 0.5x squared. Press enter, and again, it's going to give me all this other stuff right here. Well, again, I'm not worried about any of this stuff. I only really care about the part over here where t is greater than or equal to 1, or 0, excuse me. And I just type in, it just looks crazy. Alright, so anyways, next I'm going to graph just 3. You see why they say use a calculator on this one? This is pretty nasty to solve. Type in 3, and I just find their intersection again. Again, we don't like the 2.2, so we're going to hover over that, press enter, and then just the plus sign. And we get t equals 2.196. Now, they would accept the 0.195 as well. So how many points is this worth? Again, 1 point for setting it up. 1 point for your answer. It's a very easy question here. All right, part D. It says find the total distance. So to get total distance from 0 to 1, that's our integral from 0 to 1, the square root of x prime of t squared plus y prime of t squared dt. Remember, to get distance, we do that because distance is just really the integral of our speed, right? It's just we just integrate speed basically is what we're going to do here. So that's what we're doing. So we just type this all in our calculator from 0 to 1. Well, what is x prime of t? Well, we already have this integral right here. But write it out again. T squared plus e to the 0.5 t squared dt. Do not forget your dt right there. And we just type this in. Go to your home screen. Menu 4-3. From 0 to 1. And I'm just going to type in my integral. Control square root. This becomes escape, hit the wrong button, cosine x squared plus, open a parenthesis, e to the 0.5 x squared dx, and again make sure you type it in correctly. Yep. Press enter, and it gives me this weird little error type thing. Basically, this is so hard for the calculator to do that it's just giving you your best guess. It's like this is as close as we can come to the actual answer, and that's your answer. Don't worry about that. Just ignore that. That's your answer right there, and that is correct. We get t. Whoops, sorry, that's not t. This is a distance. We would get 1.595, and they would have accepted the 4-2. So how many points is this worth? Again, you're going to get 1 point for your integral, 1 point for your answer right here. So don't skip on the work. This did not take us very long. Give you more time to go back and check number 1 if you might need to. All right, keep going. We'll go to number 3 next. That is non-calculator. I'll see you.